สวัสดีผู้เข้าร่วมสัมมนาทุกท่านนะครับขอขอบคุณทุกท่านที่ได้ให้ความสนใจในการสัมมนาของศูนย์บูรณาการเทคโนโลยีอาคารและการก่อสร้างมหาวิทยาลัยศิลปากรนะครับขอต้อนรับทุกท่านเข้าสู่การสัมมนา CIBCT ครั้งที่5นะครับในหัวข้อ German Way of Building Design นะครับกับผมทยากร จารุชัยมนตรีอาจารย์ประจำคณะสถาปัตยกรรมศาสตร์มหาวิทยาลัยศิลปากรทำหน้าที่เป็นผู้ดำเนินรายการในครั้งนี้นะครับพร้อมกับอาจารย์ปูปรีชยามหัฒนทวีอาจารย์แตงพารวีโพคาวัฒนานุรักษ์และอาจารย์ยุ้ยบุญดายงวานิชกรนะครับ Good afternoon ladies and gentlemen. It is a great honor to welcome all of you to the 5th CIBCT seminar. The topic of this seminar is German Way of Building Design. I am Tayakon Jaruchaimantri on behalf of Faculty of Architecture, Silapakon University. It is my great honor to be the moderator today with ปูปิชยามัทนาทวีแตงพารวีโพคาวัฒนานุรักษ์ and ยุ้ยบุญดายงวานิชกรนะครับอย่างที่ท่านทราบนะครับผมว่าในการดำเนินโครงการอาคารและการก่อสร้างนะครับจะดำเนินการโดยผู้เชี่ยวชาญจากวิชาชีพต่างๆเพราะฉะนั้นการพัฒนาบุคลากรในหน่วยงานอุตสาหกรรมก่อสร้างให้มีความรู้ความสามารถเรียนรู้อย่างต่อเนื่องมีความเข้าใจบทบาทหน้าที่ความรับผิดชอบของตนเองและเพื่อนร่วมงานการมีเป้าหมายร่วมกันในโครงการการทำงานร่วมกันอย่างบูรณาการการตัดสินใจจากข้อมูลการประยุกต์ใช้เทคโนโลยีต่างๆอย่างเหมาะสมกับโครงการจึงมีความจำเป็นนะครับเพื่อให้โครงการประสบความสำเร็จซึ่งเป็นวัตถุประสงค์ของการสัมมนาในครั้งนี้นะครับ The objective of this seminar are to sharing the experience through the project or case study to inspire interdisciplinary knowledge and experience for integral design and to develop a growth mindset and collaboration. Two case studies for today's seminar are railway station of Stuttgart Airport, the deepest underground station in Germany, and refurbishment and building new rooftop apartment of an existing 60 years old apartment โดยในการสัมมนาครั้งนี้นะครับได้ยกตัวอย่างกรณีศึกษาในประเทศเยอรมนีมา2โครงการนะครับทั้งโครงการขนาดเล็กและโครงการขนาดใหญ่นะครับโดยโครงการขนาดเล็กก็จะเป็นโครงการปรับปรุงอาคารเก่านะครับอายุ60ปีให้มีประสิทธิภาพอาคารที่ดีขึ้นนะครับและมีการต่อเติมห้องพักเพิ่มเติมในชั้นบนชั้นดาดฟ้านะครับประเด็นที่น่าสนใจก็คือการออกแบบเพื่อปรับปรุงประสิทธิภาพอาคารในขณะที่ยังมีผู้พักอาศัยอยู่ในอาคารนั้นนะครับและอีกโครงการหนึ่งเป็นโครงการขนาดใหญ่นะครับก็คือโครงการสถานีรถไฟใต้ดินสนามบินสตุตการ์ดนะครับซึ่งเป็นโครงการที่มีมูลค่าสูงและเป็นสถานีที่ลึกที่สุดในเยอรมนีนะครับและเป็นส่วนหนึ่งของโครงการ S21 ซึ่งเป็นการพัฒนาเครือข่าย High Speed Train ในเยอรมนีและในยุโรปนะครับจากการสัมมนา CIBCT ตั้งแต่ครั้งที่1จนครั้งที่4ในที่ผ่านมาเนี่ยจะเป็นกรณีศึกษาในประเทศในหลากหลายมุมมองนะครับตั้งแต่ผู้พัฒนาโครงการสถาปนิกออกแบบบริษัทรับเหมาก่อสร้างแล้วก็ผู้บริหารอาคารนะครับโดยในสัมมนา CIBCT ครั้งที่5เนี้ยก็ได้หยิบยกกรณีศึกษาในต่างประเทศนะครับในบทบาทหน้าที่ของวิทยากรของวิศวกรออกแบบและวิศวกรที่ปรึกษานะครับซึ่งวันนี้ก็ได้รับเกียรติจากท่านวิทยากรคือคุณรามซานบาลซี่นะครับท่านก็เป็นชาวตุรกีนะครับสำเร็จการศึกษาระดับเทียบเท่า Master Degree ในสาขา Civil Engineering แล้วก็ Building Physics นะครับจาก University Stuttgart นะครับท่านยังเป็นสมาชิกใน German Society for Sustainable Building นะครับ Chamber of Engineer Association of Building Material Testing Institute นะครับแล้วก็เป็น Certified Checker for Concrete, Steel and Composite Structure นะครับเป็น Head of Building Acoustic Test Center นะครับแต่ท่านในมุมของการทำงานนะครับตั้งแต่ปี 2002 ท่านก็เป็น Partner and CEO ของ Werner and Balci Headquarter in Germany นะครับ 2010 ถึง 2018 Partner and CEO of Werner and Balci Stockholm นะครับแล้วตั้งแต่ปี 2019 ก็คือ Werner and Balci Istanbul นะครับจากประสบการณ์การทำงานของท่านวิทยากรจะมีความท้าทายนะครับมีการเรียนรู้การแก้ปัญหาความคิดเห็นแล้วก็เทคโนโลยีต่างๆเนี่ยยังไงรวมถึง soft skill นะครับการทำงานเป็นทีมจะมีประเด็นอะไรที่สามารถนำมาประยุกต์ใช้ในประเทศได้บ้างนะครับ Okay, please join me to welcome Herr Ramazan Balci. Please.
Thank you for your introduction. I didn't understand a lot, but I heard some German phrases.
Okay.
All right.
Can you share your slide?
I will share my screen. So thank you very much for the introduction. And so I think you should know a little bit about my person and my qualification. I'm the owner and CEO of an engineering company here in Germany. We do mainly structural and physics design of buildings, of infrastructure projects, but we also have a architectural department, MEP department, and do also consultant service. And as Mr. Pop said, that we are also checkers for concrete, composite, and steel structures. We are also checkers for acoustics. So we will talk about the biggest project in Europe, biggest infrastructure project in Europe. It's named Stuttgart 21. And mainly we will talk about the deepest station of Germany. The deepest train station in Germany will be built in Stuttgart as a part of Stuttgart 21. In Stuttgart is a city approximately with 600, 700,000 citizens. It's not that big. It's not comparable with Bangkok, but it's a center for infrastructure. I will show you later. So we will talk about Stuttgart 21 in general. We will talk about the trade airport and trade station. This will be our focus, and we will talk about construction details, and later we will also talk about acoustics. Feel free to interrupt me. Feel free to ask anytime if there is a question, if there is something you don't understand. It's easier for me to answer the question directly, not later on. So please you interrupt me if there's a need for that. So let's go on. Stuttgart 21, it's named because it should be the 21st century project. We are in the 21st century, and the project is ongoing. So what is the existing or the previous situation? We have, here you see Stuttgart. Here in the middle, you see Stuttgart. This is Stuttgart town. And you see the tracks. This is the track for east. With this track, you can go to, maybe you can go to Ukraine, to the war zone. Now we have a war in Europe. Here we have a track. You can go to the northeast. Let me say Berlin. Here is a track or line going to the north. I will write down London. Here on this left side, you can go to the west. I will write Paris. And down south, you can go to Switzerland. I will write Zurich or Italy. So I will write here Munich, or Kiev. So as you see, Stuttgart is for railway issues. It's a hub, so it's a center. And the problem is the Stuttgart main station is very old and very weak. Every train coming from, for example, from this line, riding down to the main station, stopping here, and then riding back and going to Paris. So we have, and this is the next, what I want to show. Every train is coming through this line to the platforms, staying here, waiting, and then going back and to the other place. This is a so-called dead-end rail hub. We have 16 platforms. The problem is that we have only five tracks at this point. So some trains are waiting here that the tracks are free to leave the Stuttgart airport. This is a big issue. So and you can't widen it because there's no land to make extra tracks. Another thing is that we have housing and buildings around the train station everywhere and the tracks. And because of sound problems, the trains are only allowed to ride with 30 kilometers or 40 kilometers per hour. So it's also a speed issue. And we have the capacity is reached, so there are trains waiting. We have a lot of delays and a lot of problems. And also you see here a lot of crossings. And these are special railway points which need to be repaired in a certain time, and this is also a big problem of Stuttgart. And as I showed, we are in the center of Europe, but we have the weakest train stations, so it was decided to change it, to build a new train station, new tracks to make it more efficient. It's a problem because Stuttgart has no extra land for a new train station, so the only thing to do is to put this train station into the ground. And this is this will be the new solution. The trains coming from here will go to the main station and pass without riding back through the train station. So this will be the new solution. We will later focus on this train station. This is the new airport train station where our office is mainly designing. You see also numbers. Here you see 1.1, 1.6, 1.3, 1.4, and so on. Our company is working on 1.1, 1.6, and 1.3. And today I will talk a lot of 1.3. Black are the existing tracks. Gray tracks will be removed. So we will not have these gray tracks anymore. So what does it mean? It means we need to build 120 kilometers of new tracks. We need to build 4 new stations. We need to build 33 kilometers tunnels, 18 bridges. And the biggest gain is we will have free land because the tracks will move down under the ground. So we will have 100 hectares of land for city development. This is 1 million square meter of land and downtown in Stuttgart, in the heart of Stuttgart. The next improvement is we can ride with 250 kilometer speed, so it's also very efficient. We will increase the capacity, and the solution is that approximately 18 million trips will move from car to the railway. So the people will ride more by train than by car. And it's also good for the environment. Here again, this is the airport station. This is the main station. We will talk about the main station a little bit and then later focus on the airport station. So just to understand what is going on in Stuttgart, it's only an overview, it's not in detail. I showed you the numbers. We have 1.4, we have 1.3, we have 1.2, and so on. our company is working on 1.6. On 1.1, this is the train station here in Stuttgart. Here, this is 1.1, and 1.3, the airport. This is the airport station. This is the main station, and these two projects will be my part here in this seminar. Okay.
จากการที่วิทยากรท่านได้พูดถึงนะครับผมลักษณะก็คล้ายๆกับหัวลำโพงบ้านเราเลยนะครับก็คือเป็นลักษณะสถานีที่วิ่งเข้ามาแล้วก็จบอยู่แค่ตรงนั้นไม่สามารถจะวิ่งผ่านไปได้นะครับซึ่งบ้านเราก็ขยับไปที่บางซื่อใช่ไหมครับแต่ถ้าลองดูแทร็กรถไฟของบางซื่อเนี่ยก็ไม่ใช่ลักษณะการวิ่งผ่านซะทีเดียวเหมือนกันนะครับเพราะฉะนั้นอันเนี้ยก็ปัญหาของเขาก็จะเป็นลักษณะคล้ายๆกันกับบ้านเรานะครับแต่แนวทางการแก้ไขของเขาก็อาจจะเปลี่ยนไม่เหมือนบ้านเรานะครับโอเค
Okay, so I talked about extra land. So this is a photo. Here are the existing platforms of the existing train station. So after we put all these tracks under the ground, we will have 1 million square meter of land in Stuttgart downtown for free. And this is for the city development very, very good. So here you can see what will happen in 20 years maybe if this land is developed. We will have green areas. Here you have green areas. We have office buildings. We have apartments and so on. It's a big gain for the city of Stuttgart. Another thing is, I told you the speed and the efficiency. So for example, if you want to ride from Stuttgart to Munich to Ulm, you need 54 minutes today. But this is 54 minutes if you have no delay. I told you that we have delays because the tracks are busy and some points are not working. So it's the minimum today we have. In future, we will have only 28 minutes with the new train station. So it's very efficient. For example, from Tübingen to Stuttgart Airport, you need 1 hour, 4 minutes. Later, you will ride in 35 minutes. So it's also a big gain for the people riding by train. For example, Stuttgart Munich, now you need 2 hours and 20 minutes, and later on it will only 1 hour 40 minutes. So the train station will be more efficient. I'm riding by train many times. I use the existing train station, and I need to arrive 20 minutes earlier because some trains are starting earlier, some trains have delays, and so I have time to adjust. And also I calculate half an hour for arrival, tolerance for arrival, because I know Stuttgart Airport is a big problem. Stuttgart main station is a big problem. Other train stations in Germany do not have that kind of problems. So here again, the city of Stuttgart and what will be built. So we will have new tracks coming from here to the new train station. We will have the airport connection here, and we have the connection to the north and the connection to the east. And this is the new big central station. It is the construction work, the concrete work is already finished. There will be a train station, a small train station here, and there will be a maintenance station where the trains will be repaired or parked in the east. And yeah, that's it. The new train station will only have 8 platforms. The old train station has 16 platforms. So it's more efficient because you have not this waiting time of the trains. And the people, if I arrive in Stuttgart For example, on platform 15, I need to run with my luggage to platform 1. Later on, we only have 8 platforms. It's also for the people easier to go from one platform to the next. So here on this photo, you see the old tracks, the old station. And later, the new station will be underground, under the ground, and cross by 90 degrees. So it totally changes the track direction. And this land will be later on a new district of Stuttgart. Here's a visualization. This is the old train station building. It was built 100 years ago. It's a historic building, so it's not allowed to demolish it. But later on, this is what we can see of the train station later. The entire train station will be underground, and you can walk and by feet directly over without any stairs. So for handicapped person, it's a direct connection without any stairs. Platform length 420 meters, 8 platforms, as I told. And these photos are not the latest photos, but you can see the concrete work is already finished. And these light eyes, as we see here and here, they will have a very positive effect. You will have a lot of daylight in the train station. You will not feel like in a tunnel. It's like a roof. And they are here, these spots. These are the light eyes. And our company designed these cup-shaped columns. We were in charge of this formwork of this shape. Here you see a sample how they cast it. It's concrete. It's not plastic or plaster or metal sheet. It's casted in concrete, and it's also white concrete. So it's a special concrete without painting. So it's directly concrete. There will be no painting. There will be no cladding or something like that. And you see the reinforcement. It's very complex, and also the formwork and how to hold the formwork here. It's very, very complex. And this is the first part casted, and then this formwork structure will be put together, as you see here, and surround the first part, which is casted. And later on, this is a top view after the reinforcement work. Here's the light eye, where will be a glass covering. And then after casting, one column is finished. To understand the height, you see here a car. This is a car. So it's a really very high column. We are talking about 1,500 tons of concrete. And our company did this shape, design of this shape. Yeah, it will be very beautiful, and in my point of view, it's a very, very big gain for the city, also for the people traveling to Stuttgart, because if you ride by train in Europe, you will see almost the standard train stations, and it's really boring. But if you arrive in Stuttgart, you will see something special. Yeah, it's totally new. Okay. Now we will switch over to the airport train station. Pop, do you want to translate this light eye cup-shaped columns, or shall I go on?
อย่างที่ทราบนะครับผม วิทยากรได้บอกไปแล้วว่าคอนกรีตที่ใช้เนี่ยก็ระดับผิวคอนกรีตเปลือยนะครับซึ่งอันนี้ก็เป็นสิ่งที่น่าสนใจเหมือนกันเพราะว่าในบ้านเราเนี่ยสถาปนิกหลายๆท่านเนี่ยก็อยากจะได้มุมของคอนกรีตเปลือยแต่สุดท้ายเนี่ยก็จะเป็นลักษณะคอนกรีตเปลือยแบบถอดโมออกไปแล้วก็สกิมผิวนะครับซึ่งสุดท้ายเนี่ยมันก็ไม่ได้มีระยะเวลาอันที่ทนทานได้นะครับอันนี้ก็เป็นสิ่งที่น่าสนใจอันนี้ไม่ทราบว่าจะมีใครจะมีคำถามเพิ่มเติมแทรกในประเด็นนี้ได้เลยนะครับผมมีไหมครับไม่งั้นเดี๋ยวอาจจะเชิญท่านวิทยากรต่อในส่วนของAirport Station นะครับผมโอเค thank you let's go
Okay, so we will talk about this was the train station. Now we will focus on the airport station. This is our focus now in our office. We are working on the airport station. The airport station is from architectural view is a very simple station. It's not that nice. We don't have that nice columns like in the main station, but it's the deepest train station in Germany. Just to understand the location, I will zoom in a little bit. This is the main motorway number 8, called number 8. This is the main motorway from east to west, passing through Stuttgart. Here's the airport of Stuttgart. We have the metro line called S-Bahn going this way. We will have the Gäubahn, the blue line train coming from Switzerland and Italy. We will have the tunnel coming from Stuttgart center. So here we will have a hub for motorway, for cars, for aircraft, for metro, for high-speed trains. So it's a hub of traffic. This buildings here you can see is the new exhibition center of Stuttgart. So to understand, this is maybe not for the people living in Stuttgart, but for the people coming to Stuttgart, it will be the station, it will be the main traffic hub, because here's the airport. If you ride by car, you will take this motorway. So this station might be also very important for this project in Stuttgart. We will have 25,000 passengers per day, and during exhibition it might be nearly 40,000. And you see here the new train station. This is the new train station, and the tunnels are crossing the exhibition center. This is the exhibition center. The tunnels are going directly under the existing airport buildings. We are crossing the motorway here, the motorway here, motorway here, and here, and here. So this was the reason why the tunnels are so deep in the soil. But it has to be also very close to the surface, because the people need to use this train station. Therefore, it was in a deep depth of approximately 30 till 40 meters. But it's the deepest train station in Germany now. Here you can see a view from top to understand the train station and the tunnels. This is the train station here. From here to here, this is the train station. And you see the tunnels under the exhibition halls. You see the tunnels under the airport buildings. You see the crossing of motorway, a lot of crossing of motorways. So it's a complex project, but it's a very important project for all the people. For example, if you want to go to the, one moment. If you want to go to the exhibition hall, you come by car, and you can park here in this is a parking building, and go to the exhibition hall. you can also park here and take the train to go down to downtown Stuttgart. Because it's hard to find a parking lot in Stuttgart, you can park here and ride to downtown. Or if you arrive by plane, you take the train station and then you can ride to your to where you want to go. The train station, here is a good photo, a view. These are the existing buildings and here are the tunnels. So we have a little bit soil between. So it was the reason to move it upward would be risky for the existing buildings. To move it downwards would be better for the existing buildings, but you need all the people need to go down to the train station platform. So this is the optimum height under the soil, under the surface. So the train station exists of the central entrance, the big entrance. We have a smoke extraction, and we have the eastern entrance. We have 3 buildings going to the surface, and we have the long tunnel, the long platform for the trains. Because it's very deep, the most important thing of this station is smoke extraction. We will have, in case of a burning train, the people waiting here on the platform, they need to find a way to go out of the train station, for example, that way. And smoke is a big issue because it's very deep. We need ventilators. There are big ventilators. We are talking about 1.2 million square meter per hour extraction power. And there are big ventilators here and here and here and also here. In total, we have 12 ventilators for 1.2 million cubic meter per hour air extraction. And these ventilators are that big, so 2 stories high, a diameter of approximately 3 meters each ventilator. And therefore, we need also a lot of electric power. There are 3 transformers installed here only for these ventilators. So in case of fire, let me draw it here. In case of fire and in case of smoke, the smoke will be extracted out of the platform, for example, that way. And the people here, they can breathe and walk to the elevators and staircases. Okay, this is the this will be the new central entrance of the airport train station. So we have, as I told, we have the, sorry. We have these platforms, the tunnels, and we have 3 buildings: central entrance, smoke building, and eastern entrance. We are 29 meters under the soil from here measured down to the platform. We have 29 meters. Here we are a little bit higher. We are close to 40 meters. So the structure of the central building is concrete structure, mainly concrete structure. We have micropiles, we have footings, we have a post-tension slab, and we have a steel structure here in the middle. And very important and very something special is this membrane. There's a membrane roof, and this membrane roof is a cushion. It's like a balloon. You blow it up and with air pressure, and it's stable because of the air pressure. We will talk later about this. Okay, so this green building, as you see, is a concrete building, and it will be built later after the underground work is finished. This is the steel structure. It's a wide span steel structure without columns. Here we have the eastern entrance building, and it's an elliptical building, a two-story concrete building, and it was not allowed to build foundation here, for example. Therefore, we used post-tension slab. Just to draw, to show you, we have the shafts going to the ground, and we have the elliptical building here. And the forces coming from left and right, we need to bring them to the center, and therefore we have a very strong, we are talking about 1 meter post-tension slab. And these are the post-tensioning areas. You see this zigzag concrete shape there. Okay. The situation on site is that the underground works are going on. We are not finished almost, but it will take, let me say, 6 months, and then we can start with the buildings. So here we have the underground work is going. The platform will be, the tunnel is walking that way, it's passing that way. And you see the huge crane here. This is a huge crane to bring the machines up and down. This is a photo from, yeah, 24th of January. So let's talk about the roof structure of the entrance building. As I said, we have a membrane roof. It's do you have membrane roofs in Thailand?
Yeah, just a small one.
A cushion which is blown up with pressure air.
Not just a temporary structure, not the permanent.
Okay. So we have a span of 20 meters, and this is the cushion. This is the shape. And there's a, let me say, a big pump here, and we are pumping air into this cushion. So there will be always air pressure between these membranes, and it's a structural system. So the biggest problem of this roof is if we have a problem with the pumps, if we have a leakage, and we have a loss of pressure and a lot of snow. I know you don't have any snow in Thailand, but if we have a lot of snow load here or water, the system will collapse and hang. And if we have later on or at the same time a lot of rain, then we will have a water sac. And we calculated this load case, and we had 250 tons of water in this membrane. And you have to imagine, one moment, I will show you. So you have to imagine you are the guy with coming from Bangkok and waiting here. And here you have 250 tons of water hanging on the membrane. And if this will collapse and fall down, 250 tons of water of a height of approximately 40 meters, I don't want to imagine what will this water do with you down at the platform. So therefore, we were asked to change this system. So for architectural reasons, it would be very nice to have only one membrane, but for safety reason, it was not allowed to build it that way. Therefore, we searched for a solution how to support the membrane. There are different systems. You can make a rectangular system like that. Let me say that. So to support the membrane, you can use radial arms to support, or you use something like a tensegrity system. And we calculated everything and also the cost efficiency. And at the end, the client, German Railway, decided to do the tensegrity system. And there's a sample just for your understanding how it would look like. This is the system, but we will not have so many bars like here. We will have less. And we will have also a membrane here in the middle. So it will be very transparent. The aim is to have as much daylight as possible on the platform. Okay. The steel structure, and now you can see the supporting system for the membrane. So the membrane, even if there is a loss of pressure, it will not collapse and will have water sac. Okay. Let's talk about the foundation. It was also not that easy because we have a tunnel in 30-meter deep. We have a tunnel project, and if we build with big piles, we would damage the tunnels. So we were only allowed to use so-called micro piles. Do you have micro piles in Thailand? Do you know this system?
Yeah, micropie. Yeah.
Okay, it's a steel pile. It's a very small steel pile, and the capacity is not that big. Therefore, we had thousands of these piles here. You can see everywhere the small piles. This was the solution to bring the load in the soil. We have the post-tensioning slab. In this area is post-tensioned. And this area we have no tendons. It's standard reinforced concrete. The reason why we use that kind of foundation is that there can be built rainwater tanks under the building. So you can have rainwater tanks to make a storage for rainwater and be independent. This is the reason. Okay. These are the micropiles. So if you know what this is, we are talking about a bar of 40 millimeters, and this is something like that. And we had also post-tension slab. I know you use this system also in buildings, but we used here very strong tendons. We are talking about tension force of 4,000 kilonewton or 400 tons of tension force. And yeah, I think you should know how to install these tendons and how to make the tensioning and so on. The Eastern building, we had a problem. There was no chance to build any foundation. So we have no foundation, and we are talking about a span of, let me say, 7 meters. So we made this with 1 meter thick base slab and post-tensioning at this area. So we have post-tensioning here, we have the post-tensioning here, and we have reinforced concrete. And the shape of the tendons is that way. The force is not that high. We have 2,400 tensioning force. And now the biggest problem of this project is the acoustics. So as I told, our office is an acoustic expert. We are listed in the top 10 of acoustics in Germany. So we tested the evacuation situation. Where I told you about this ventilators. We have the huge ventilators with 1.2 million cubic meter per hour capacity. And the problem is that in case of fire, if we run these ventilators, it will be very loud. It will be very, very loud. And so if there, for example, if a burning train arrives at this train station, the fire alarm system will run, the ventilators will start, and it will be very loud. The speech alarm system, for example, if you are a guest of this train station and the speech alarm system is telling, please leave the train station, please use the next staircase to leave the train station. The speech alarm system is not possible to be understandable. I want to show you acoustic simulation, how it will be. One moment. So I hope you can hear it. This is the situation before. So you hear someone speaking, the speaker, the alarm system, but the ventilators are that loud that you can't understand anything.
It's not just to hear volume.
And this is the situation after.
It refreshes our minds, soothes our hearts. It can make us happy, or sad, or excited. It also is essential for communication of ideas and the exchange of information. It's vital to daily life.
So we had first we didn't understand anything. In the second simulation, it was still very loud, but there's a chance to understand the speech alarm. So what is the solution? We changed the segmentations. We changed the exhaust, the smoke extraction system. We use more efficient ventilators and quiet ventilators. We installed a lot of sound absorbers. To understand, we used these panels with sound insulation and sound absorption. We used the roof. We used acoustic elements to optimize the situation. Sound absorbing systems. And we used better speakers. And at the end, it was enough to have a sound quality that the speech alarm system will work. And do you have any question, or Mr. Pop, do you want to translate it?
Yep. Yeah. Okay.
Yes, there's a question from the audience, Amanrat, because this is a very complicated project. So is there any issue with the community, such as like a land expropriation or the environment issue? Because it's a huge renovation project and needs lots of like cooperation from many parties. And in terms of the construction, you go down very, very deep, right? You said like 30 or 40 meters. So there must be a lot of work with the existing structure and also the urban planning that you have to work in the existing structure from the city. And also like the transportation of like the material to go down underneath.
Yeah.
Yeah.
Oh, this is the last point you said is a very very big problem, because we will need to build very fast, and we have only these 3 buildings to bring materials down. And you have seen this huge crane and this huge opening for the tunnel work. So it's a big problem. Later on, it will be we will close this big opening and we will remove this big crane, and we will work with small cranes, and this is a big problem. So therefore, we use special elevators for the construction works. We will have 5 elevators to bring the people and the workers and the materials down to the train station. Another thing is the environmental problems. For example, this soil material you will bring out of the tunnel. It is be tested and washed and used again. For example, for reinforced recycling concrete, we call this recycling concrete, for road works and other things. And also we have very high. We have a green party government here, so that means environmental issues are very important. For example, if there are special birds living close to this area, they need the construction company needs to build special camps, let me say camps or trees for these animals to not to disturb their area. Yeah, this is a big problem. Also, we have an ongoing airport. So there's an airport working. We have an ongoing motorway working. We have an ongoing exhibition hall working. So this airport project is also very difficult, as we have these difficulties at the Stuttgart main airport, main train station. I'm sorry.
And how about the people, like the people in that area? Are they okay with the construction like this big and 6 years?
Yeah, there are a lot of protests again. There were a lot of protests against this project, for sure, because it's loud. It does cost a lot of money. And for environmental reasons, all trees need to be cut and so on. Therefore, we had a lot of protests. But it was at the end, it was a good solution to have an election. Pro or contra for this project, and I think it was 65% of the people wanted this project. The construction work is really not an environmental friendly solution. Any construction work is not environmental friendly, but we need to look at the end of this the solution. The solution is we will have a very efficient railway system, very efficient, and the people will more use the train system, the railway system, and will not use the cars. And I think we have to look on the solution of the project. Construction work, okay, it's not eco-friendly. It's loud. It's dusty. It's damaging a lot of old trees and animals. There are impacts. But the end solution, you have seen in Stuttgart this big track area. It will be removed, and then you can develop the city totally new.
Yeah. Thank you.
It was a big problem in the past. But now I think the people accepted it. But it's very hard to build in Germany. You need to test everything. You need sustainable. You need to use only sustainable materials. You can't use plastics. Blah blah blah. It's really hard to build here in Germany. I know it because in other countries it's very easy.
But it's like it's good because you have like really high standards in construction. So
yeah.
And maybe because people start to see the form and the shape and the thing like this construction is worth.
Mhm.
Now, I mean,
The problem is also, for example, this project will cost more than 10 billion euros, maybe 15 billion euros at the end. But it's a huge amount. It's really a huge amount. But this is money. If we don't spend it in Stuttgart, for example, it will be spent in Hamburg or Berlin because it's money for transportation. So we all pay the tax. Also, the people in Stuttgart pay the tax. And the money will be invested in other cities. With this money, the government will not build schools or hospitals or something like that. This is transportation money, and this transportation money needs to be invested in transportation projects. So if you think that way, okay, if we don't build this train station in Stuttgart, the government will invest this money in other areas. Maybe no one need a train station in another area, but this money needs to be invested. And therefore, if you think that way, it's better to invest it in a good project. So I think 2026, this project will be finished. All of you are invited to come to Stuttgart and come to the Stuttgart airport and take the train to the downtown Stuttgart. Okay, I want to show you, yeah.
I have some questions about like the type of membrane. What is the type of membrane being used for the roof structures as a translucent material?
It's a ETFE. It's a ETFE material, and it's really transparent. So it's like glass.
And like
you can it's light transparent, and it's a foil about 0.2 millimeters. It's
Yeah.
very thin. It's the own weight is almost zero.
is that popular in Germany with that material?
It's popular if you watch football, soccer. The facade of Allianz Arena of football club Bayern München is covered with this membranes. But this 20-meter dimension is a very big dimension. So it's normally we have membranes about 4 or 5 meters.
And after you're adding structures, do you structure in membrane? Like, is it change a lot about the amount of pressure that need to put inside the membrane?
We are talking about 500 Pascal pressure. The pressure is the same. The problem is we can't increase the pressure because you will have too much tension in the membrane. It's like a balloon. You can blow up a balloon and then it's exploding, and you are not allowed to have too much pressure. So the pressure must be in this project we use 300 till 500 Pascal. So it's not more safe to have more pressure. So if we have a pressure, and if we have a lot of snow, the snow will push the membrane downwards, and the pumps bringing the pressure cannot avoid that the membrane will have a deflection. And then it will we will have a water sac, and with combined with rainwater, we will have a water sac, and there's no chance to do it with pressure. There's no pump to push it back, to push the water and the snow away from the roof. It's not possible.
Thank you.
But it's a for example, in countries like Thailand, where we have not this snow problem, this membrane roof would not be a big problem, because rain will fall down and will drop to the side because of the inclination of the membrane. So we will not have a water sac problem. So if we have a drop of water, for example, this can move downwards, but snow will lay down on the membrane, and then it will be flat. Let me say the membrane will that way, because here inside we have a pressure in the membrane, but it will be flat. And if it starts to get flat, and if we have rain, then we have water sac, and we can't bring the membrane back. So we will have water sac, and we need people going on the roof and pump this water out of the membrane to push the membrane back again. This was the reason why we supported the membrane with this structure here. Okay.
Thank you very much.
I want to show you just a small video about our project in Stuttgart. These are the new tunnels. Here you see the construction site of the main station, the light eyes. And you see, everything is done with an ongoing infrastructure. There are trains crossing, or people crossing, or cars crossing the construction site. This is a very nice bridge. It's a steel structure. It's like a suspension bridge, but it's done with steel plates, not with tension rods, tension tendons. The main station. These are the 8 platforms I talked about. And this is the existing historic building on tiles. Between these tiles, on this tile there is an old historic building, and our train station is crossing this old historic building. This is the old historic building. Now on the main part of Stuttgart Airport. Here are the big light eyes. They are really big. As I told, 1,500 tons of concrete per column. This is the south of our train station, Stuttgart. Now we are moving with the tunnel to the airport, to the latest project I showed you, the airport station. Cross the motorway. I told you the motorway is the most important motorway in Stuttgart. The big machine you see is 100 meter long to the end. Here you see the big crane. I explained to you the big crane for the tunnel work. This tunnel is to cross the motorway. It will go down under the motorway. This is a small bridge, not that important. So, I think this is enough to understand our project. Okay.
Okay.
That's
Moment.
the first project. Are there any questions?
Yep, moment between. Let us translate about the answer and the question. อาจารย์ยุ้ยอาจารย์แปงเดี๋ยวอาจจะลองสรุปคำถามกับคำตอบเมื่อกี้นิดนึงครับ
ก็ได้ค่ะพอดีจริงๆแปลไว้ในแชทแล้วค่ะแต่ว่ามันหลักๆก็คือเขาพูดถึง2ประเด็นนะคะอย่างแรกก็คือปัญหาพวกสังคม สิ่งแวดล้อมเนี่ยคือมันมีการประท้วงเกิดขึ้นซึ่งเขาก็ทำประชามติประชาพิจารณ์มีการโหวตจากประชาชนอะไรเงี้ยค่ะซึ่งมันก็จบลงที่ประมาณ 65% ที่ บอกให้สร้างแต่ว่าจริงๆก็คือเกินครึ่งมันไม่เยอะแต่เขาก็ถือว่าทุกคนจ่ายภาษีแล้วก็เงินเนี่ยมันมีการจัดสรรชัดเจนว่าเงินตรงไหนเอาไปใช้อะไรทีนี้เงินส่วนที่เขาเอามาก่อสร้างเนี่ยถึงมันจะหลายล้านยูโรอะไรอย่างเงี้ยแต่ว่าเขาก็ถือว่าเขาใช้เงินในส่วนที่เอาไว้สำหรับสร้าง transportation ไม่ได้ไปเอาเงินส่วนของโรงเรียนหรือโรงพยาบาลหรือส่วนอื่นๆมาใช้ไม่ได้เบียดเบียนส่วนอื่นอะไรเงี้ยค่ะแล้วก็ไม่มีการก่อสร้างไหนที่มันไม่ทำลายสิ่งแวดล้อมแต่ว่าเขาก็พยายามที่จะรักษาสิ่งแวดล้อมให้มากที่สุดมีการเอาสัตว์ต่างๆเนี่ยย้ายไปอยู่ที่อื่นหรือว่าปลูกต้นไม้อะไรอย่างเงี้ยที่แบบว่าอนุบาลสัตว์อะไรเงี้ยค่ะแล้วก็มีรัฐบาลปัจจุบันเนี่ยก็สนับสนุนพวก green construction อยู่แล้วเพราะฉะนั้นเขาก็จะพยายามใช้พวก material ที่รีไซเคิลได้อาจจะเป็นคอนกรีตที่รีไซเคิลหรือว่าพวกไม้วัสดุที่มัน sustain ต่างๆนะคะทีนี้พอมาถึงเรื่องปัญหาด้านการก่อสร้างคือเนื่องจากมันก่อสร้างไปลึกใต้ดินมากๆใช่ไหมคะมันจะเป็นสถานีรถไฟที่ลึกที่สุดในเยอรมันและปัญหาหลักก็คือเป็นการขนส่งนี่แหละทั้งคนทั้งวัสดุเพราะว่าเขาต้องเอาเครื่องจักรเอาเครนขนาดใหญ่มากๆขนลงไปก่อสร้างใต้ดินเป็นอุโมงค์ยาวใช่ไหมคะเขาก็เลยเหมือนมันมีแค่3ตึกเท่านั้นเองที่เขาจะสร้างลิฟต์ใหญ่ๆที่เอาไว้ขนเครนขนเครื่องจักรแล้วก็มี3ตึกในที่นี้หมายถึงว่าในไซต์ทั้งหมดเนี่ยมันเขาจะก่อสร้างลิฟต์พิเศษอะค่ะอยู่ในแค่3ตึกแล้วก็จะมีลิฟต์5ตัวเท่านั้นเองที่เอาไว้ขนคนงานซึ่งมันก็ต้องวางแผนเพราะเขาต้องก่อสร้างให้เร็วที่สุดอะไรเงี้ยค่ะแล้วก็พอช่วงท้ายๆของการก่อสร้างเนี่ยก็ค่อยๆลดจำนวนลงใช้เครนที่ตัวเล็กลงอะไรอย่างเงี้ยแล้วก็ค่อยๆลดจำนวนลิฟต์พวกนี้ค่ะ
จันแตงครับจันแตงมีสรุปเพิ่มเติมครับก็เดี๋ยวเพิ่มเติมนะครับก็คือว่าปกติก็เป็นเรื่องปกติของการประท้วงในเยอรมนีอยู่แล้วนะครับซึ่งเมื่อกี้ก็ท่านวิทยากรก็ได้พูดแล้วว่าจริงๆมันเป็นเรื่องการเมืองด้วยเรื่อง politics นะครับมันก็มีพรรคกรีนนะครับพรรคกรีนพรรค CDU พรรคทางการเมืองเนี่ยและอีกอย่างหนึ่งคือการก่อสร้างตรงนั้นเนี่ยมันสถานี main station ของซิกาเนี่ยก็เรียกว่าเป็นcultural heritage อันหนึ่งด้วยอันนี้ก็มีเป็นประเด็นเหมือนกันเพราะว่ามันอยู่ข้างๆเลยนะครับแล้วเรื่องธรรมชาติจริงๆแล้วข้างเคียงเนี่ยก็จะมี natural heritage อยู่ข้างๆด้วยนะครับเป็น Palace Park นะครับหรือ Schlossgarten นะครับประเด็นที่อาจารย์แตงสอบถามเรื่องวัสดุอาจารย์แตงจะสรุปไหมครับก็คือตัวคูชั่นตัวเป่าลมใช่ไหมครับก็คือเป็นวัสดุที่เรียกว่าถ้าลองเซิร์ชตัว Stadium Alliance นะครับของใครเป็นแฟนบอลของมุนเช่นก็น่าจะเห็นนะครับเป็นตัวคูชั่นซึ่งในประเทศไทยเนี่ยถามว่าก็หาอยู่ไม่ค่อยเห็นแต่ก็แอบมีบ้างนะครับก็อาจจะมีบ้างถ้าใครมีคำถามเพิ่มเติมในเกี่ยวกับโครงการแรกนะครับก็อาจจะลองคำถามมานิดนึงนะครับลองพิมพ์มาในแชทนะครับเมื่อกี้อาจจะขออนุญาตสรุปสั้นๆนิดนึงที่เราเรียนรู้จากโครงการแรกนะครับผมก็จะมีในเรื่องของที่ท่านวิกรบอกว่าตอนแรกเนี่ยดีไซเนอร์ก็อาจจะต้องการโครงสร้างเป่าลมแบบ no structure นะครับเป็นตัวมันเองแหละที่เป็นโครงสร้างเลยสุดท้ายก็มีการพูดคุยปรับเปลี่ยนรูปแบบขอแทรก structure เข้าไปเพราะว่ามันอาจจะเป็นไปได้ยากอะไรอย่างเงี้ยครับก็มีการสื่อสารพูดคุยกันระหว่างดีไซเนอร์ด้วยนะครับแล้วก็เรื่องของโครงสร้างที่ท่านวิทยากรพยายามอธิบายนะครับว่าส่วนไหนใช้ post tension ส่วนไหนใช้ reinforced concrete ธรรมดาก็ทุกอย่างก็จะ based onข้อเท็จจริงเรียกว่าตัว structural model เป็นยังไงส่วนไหนควรจะใช้ส่วนไหนใส่ไม่ได้เนื่องจากว่าจะต้องมีถังเก็บน้ำใต้ดินก็ไม่สามารถใช้โครงสร้างฐานรากได้ก็เปลี่ยนเป็นไมโครพายแทนนะครับซึ่งไมโครพายในประเทศไทยก็มีใช้ทั่วไปนะครับในการรีโนเวทอาคารอะไรพวกนี้นะครับอาจารย์แตงมีเสริมอะไรไหมครับผม
เมื่อกี้ก็คือสอบถามในเรื่องของการเพิ่มเติมในเรื่องของ air pressure คือตอนแรกเนี่ยเขาไม่ได้ใส่ structure ไปนะคะแต่ก็คือเขาก็บอกว่าในเรื่องของ air pressure ก็ยังเท่าเดิมค่ะเพราะว่าถ้าเกิดมากไปน้อยไปก็จะมีผลในเรื่องของการ collapse กันในเรื่องของการไม่สามารถคงรูป structure ได้ค่ะส่วนของประมาณนั้นค่ะ
ขอบคุณครับ thank you very much please another questions อันนี้เป็นเกี่ยวกับโครงการนี้ใช่ไหมครับโครงการtrain station เกี่ยวกับการจัดการพลังงาน Excuse me another questions about the project do you have any like energy
Energy?
how to conserve energy conservation in the first project that you present
The train station project, yeah, it's
Yeah.
what kind of energy saving can we do? The German railway authority is 100% using renewable electric power. So it is not coal, gas, or nuclear energy. It's renewable energy. And in the buildings, we have the problem, the most energy consumption or energy demand is if we have emergency situation like fire. Then we have this big 3 transformers and this big ventilators working, and we can't do it with solar panels and batteries. It's a huge energy demand. We are talking about nearly 1 megawatt. So it's not possible to build some solar panels on the roof. But for heating and cooling, we have used very good insulated glass, very good insulated walls and roofs. So for heating and cooling, we have a very efficient solution. But for electric power, as I said, the German Railway Authority is using 100% renewable electric power.
Thank you ครับก็ส่วนใหญ่เวลาออกแบบก็จะเป็นเรื่องของการออกแบบประสิทธิภาพของตัวอาคารอยู่แล้วนะครับไม่ว่าจะเป็นเรื่องฟาสาดเรื่องกระจกนะครับผมซึ่งก็ในเรื่องของพลังงานก็จะมีเรื่องของ renewable energy นะครับผมซึ่งก็เป็นพลังงานสะอาดนะครับก็จะเน้นประมาณนั้นนะครับมีคำถามเพิ่มเติมเกี่ยวกับโครงการแรกอีกไหมครับผมไม่มี
I would like to ask that is there any problem about the noise coming from the rooftop?
Noise from the rooftop?
Yes.
From the cushion
Rooftop of the exhaust systems, smoke extraction.
The main entrance.
Yes. The main roof.
The roof of the main station is glass, is not membrane. One moment. Are we talking about this roof here?
Yes.
But this is glass, and I understand the trains here are the platforms. They are not driving with 250 kilometers of speed. They are staying here. The trains are not that fast in this tunnel. So the trains, the 8 platforms here will not cause a lot of sound. The highest sound we have is in case of fire. In case of fire, when these huge ventilators are working and make the smoke extraction, this is the loudest part, but this is an emergency case. That means, let me say, every 30 years when we have a fire in the train station, it will be very loud, but okay, it's an emergency situation. But the sound caused by trains is not that loud, because in this station, the trains are not that fast. Is this understandable?
Okay, thank you ครับก็คือพี่ปูเชิญเลยครับผม
คือเข้าใจว่าเสียงที่เกิดจากภายในตัวอาคารมันก็จะดังอยู่แล้วใช่ไหมคะถ้าเทียบกับเสียงที่จะมาจากด้านนอก
ก็คือแหล่งกำเนิดเสียงพิษคืออ่าที่บอกว่าเสียงส่วนใหญ่ก็จะเกิดตอนไฟไหม้เรื่องของเครื่องจักรในการอันนั้นมากกว่านะเพราะฉะนั้นก็เลยไม่ได้เป็นลักษณะการที่จะโปรเทคเสียงจากข้างในข้างนอกใช่ไหมครับโอเคครับผมโอเคมีคำถามเพิ่มเติมไหมครับโปรเจกต์แรกไม่มีเดี๋ยวขอ please next project
Okay, let's go to the next project. Okay, now we will switch over to a very small project. We had the big project, the Stuttgart 21, and now we will make a very small. It's not a new building, it's a refurbishment, it's an extension of an existing building. So just to have I wanted to show you a big project, a new and a small one, and it's to have an overview what is design in Germany. So this I will start. So I will introduce you the project CKS. CKS is the project name. It's the street name, Christian Kneier Street, CKS. So we will talk about the condition of the existing building. What is this is a 60-year-old building. What is the situation? What are our tasks to refurbish? The challenges of the project. We have the vertical expansion challenge. We have the vertical resistance. We have the earthquake resistance. We have also sound physics and other challenges. So CKS. You see here an overview. This was the existing building, and we added on the roof an extension. So what was we had a huge demand for housing. We have still a huge demand for housing. We need every square meter, so we need to produce new areas for apartments, but there is no land. No free land, and no green land will be developed and changed to building land. So therefore, we need to use existing building land and concentrate and use it more efficient. And it's also very important. It must at the end it needs to have a fair price. Because to have luxury apartment is not that easy. You can build very expensive with expensive materials and expensive architecture and so on. But our problem is to have also for the people, for the low-income people, a fair price for rental. Our company, we have experience how to make expansions and extensions on existing structures, and also how we can refurbish the existing building. We make energetic refurbishment. You know, we have a war in Europe between Ukraine and Russia, and gas prices are increasing, and Germany is 55% of Germany's gas is coming from Russia, and so we need to reduce our gas and energy consumption, not only for the war reason, also for ecological reason. We need to reduce it. We checked if there is a chance to increase the height of the building. It was possible. We also checked the structure. If there's a structural feasibility to do it, and the main problem was the consolidation of soil of the underground, and also it has to be done during a lift situation. So the apartments, the existing apartments, needs to work. It must be functionally, because the people, the tenants, will live there without leaving this house during construction state. And this was very important, because the inhabitants, there was an agreement with the people living there. We will make a construction, but we will not disturb your life. So here you see this building again. The existing structure, you see, this was the situation before. These buildings were built in the 60s in Germany, so almost 60 years old building. It's a very, very simple structure. We have brick walls, we have concrete slab, brick walls. The energy consumption was terrible, so we decided to look in detail on these buildings. Here you see also standard windows. We have a lighting system. The entrance. Here you see the entrance. This roof was terrible. We have stairs. So for older people or handicapped person, it was not possible to live there, or very hard. You see, this is the main entrance to the house, and we have here a window. So the people entering the house can look in this room of some apartments. So it was not nice, but these buildings were built in the 60s. And in the 60s, there was also a high demand for apartments because of end of the Second World War. A lot of Germans came from old German areas to Germany, and therefore there was a huge demand. You also see here something like this colors. This is a moisture and humidity problem. Here inside also you see this gray colors. It's also a humidity problem. Then we have water infiltration. We have also a very bad situation for mailboxes. So therefore, we decided to refurbish the existing building also. Okay. Do you have any question about the existing?
มีคำถามไหมครับเกี่ยวกับอาคารเก่าที่ท่านวิทยากรได้นำเสนอนะครับก็เป็นอาคารที่เป็นอาคารเก่า60 ปีส่วนใหญ่นะครับก็มีความเสื่อมโทรมคล้ายๆบ้านเราเลยนะครับไม่ว่าจะเป็นเรื่องของผนังความชื้นแล้วก็เรื่องของอุณหภูมิที่ตัวกำแพงตัวผนังเนี่ยไม่สามารถที่จะกันความร้อนได้ดีกันความเย็นได้ดีนะครับOkay, let's go.
Let's go. So after this general development, we decided to add new apartments on the roof. So you see here, this is the new apartment on the roof. You see here an apartment. In some, we had 6 new apartments with 2 rooms. On the roof, so-called rooftop apartments. You see here the existing building, and this is what we add new. It was not allowed to build the entire. We were only allowed to use 75% from the authority, and therefore we had used this area for terrace and balcony. At the same time, we said, okay, we had a problem for handicapped and old people living in these houses. We decided to build a new staircase. So we and a new elevator shaft. So we will have a ramp for the people who cannot walk on stairs. We will have ramps to enter the building, so you can go to any apartment without using a stair, and then you can use the elevator, and from the elevator you can go also to the apartment without, and therefore we had ramps. Okay, for the younger people we kept the stairs. If they want to walk over the stairs, there's the situation. And now I told you that we did this construction with ongoing house needs to work. So if we have a construction site here, the people cannot get in their apartments anymore. Therefore, we built temporarily staircases outside, and the people entered the apartments from outside during the construction here. So this was also a big challenge. And the tenants, the existing tenants, they accepted this because later, after this project, they will have big benefits. Okay. Energetic consumption, we use cladding, new windows, highly insulated roof and highly insulated base slabs. We have 5 months, at least 5 months with heat demand, and not comparable with Thailand, but we have a big heating demand here in Europe, and therefore it's important to focus on heat energy. Okay, and to give the people living in the existing apartment also a big benefit, we added new balconies. So here we added balconies. So every existing apartment got a balcony. They didn't have any balcony till now, but after this project, they will have balconies. This is important. It's important to convince the people living there. They are tenants. They are not the owner of the building, but they have a lot of rights. And if they go to judge or court, they will mostly win because the rights here for tenants are very high. For fire reasons, we checked the fire escape situation and detected also that this is very weak. Therefore, we added 3 new fire escape staircases to have a fire safety later on. Okay, the vertical expansion, as I told, we have the existing roof slab here. And how can we extend in vertical direction? So this is the solution, how we did it. You see here the concrete slab, the existing concrete slab. We added a timber slab, a new timber slab structure, and a new timber roof slab, and timber walls. The only concrete thing we used was the staircase. The staircase extension was done with concrete material. So we use very light laminated timber, frame timber construction, and also with, again, laminated timber. So here you can see the structural system of the timber plates. You see also a lot of cutouts. You see here cutouts and openings and so on. This is necessary. This is necessary for heating, ventilation, installation, MEP installation, electrical installation. So we have an existing structure from the 1960s, and therefore we were asked to check, is the existing building strong enough to carry these new loads? Therefore, we checked, you see here a structural calculation from the 60s, how it was done in Germany. So it's a hand calculation, and it is a colleague. I met this guy, Mr. Gul, but he died a few years ago. So he was very young when he did this calculation. So we checked this existing building, the capacity of the walls, the capacity of the slabs, and the capacity of the foundation. And that was the biggest problem, was the existing foundation. The existing foundation did not have enough capacity to carry the new loads. Here you see the existing. These are the existing usage. So this orange colored foundation were used nearly by 100%. So capacity almost zero. After adding our new rooftop apartments, we would have an increase of 25% here and an increase of 6% of the existing capacity. So we need strengthening of foundation. The 6% we covered with long discussions with the geotechnical expert. So there was no strengthening required. But here in the staircase, we used strengthening measures. It was not that difficult because we need to build a shaft for elevators, so we can strengthen the foundation. It was not a big issue. Earthquake resistance. We have some earthquake in Germany. In our region, we have earthquakes, and therefore we need to design earthquake. And the existing building had 3 stories, and we added a new story on the top. And the good thing is we had a timber structure, so timber is very lightweight, and therefore it was not a problem to add something like that on the roof, and we did not need any earthquake strengthening measures. Energetic, as I told, we used insulation material. We used maybe do you have some question to the structural things? I will later talk about the building physics. Are there anything about structure?
มีคำถามเกี่ยวกับโครงสร้างอาคารเก่าไหมครับ อันนี้ถ้าดูภาพรวมก็จะเห็นว่าชั้นดาดฟ้าที่เพิ่มเติมเนี่ยก็จะเป็นโครงสร้างเบานะครับก็คือจะเป็นพื้นเป็นโครงสร้างไม้นะครับมีการยกพื้นซ้อนพื้นเพราะว่างานระบบท่อต่างๆก็จะอยู่ข้างใต้พื้นนะครับแล้วก็มีการคำนวณโครงสร้างก่อนว่าแต่ละโครงสร้างที่ existing ที่ปรากฏอยู่เนี่ยมันรับน้ำหนักอยู่ที่เท่าไหร่นะครับรับไปแล้วกี่เปอร์เซ็นต์บริเวณไหนที่พอเพิ่มไปแล้วจะต้อง strengthen หรือว่าจะต้องเพิ่มกำลังของมันเนี่ยเป็นอยู่ที่ตรงไหนบ้างซึ่งก็พบว่าบริเวณคอบันไดตรงนั้นเนี่ยจะต้องเพิ่มนะครับโดยเฉพาะงานฐานรากจริงมันก็มี factor of safety ของมันอยู่นะครับซึ่งอันนี้ก็ได้ปรึกษากับทาง geotechnic งานวิศวกรรมฐานรากนะครับว่าตรงไหนที่ต้องเพิ่มบ้างนะครับโอเค let's go
ใช่ก็คือเป็นการใช้พวก private structure อย่างเช่น laminate timber ค่ะซึ่งปัจจุบันเนี่ยอาจจะไม่ได้เห็นในบ้านเรามากนักแต่ว่าก็ในต่างประเทศก็คือเป็นวัสดุคล้ายๆกับไม้ในรูปแบบของการแปรรูปให้ความแข็งแรงแล้วก็เพิ่มสแปนได้ดีขึ้นก็น่าสนใจมากเลยค่ะ
ครับสรุปเพิ่มเติมไหมครับในประเด็นที่น่าสนใจโอเคมีกันต่อเลยนะครับโอเค Chris
or can I go on?
Go on, yes.
Okay. So energy refurbishment. As I told, this building was built in the 60s. In the 60s, we had no problem with gas and oil. It was very cheap. And now we have the problem that energy is very expensive, and for environmental reasons, we need to build energy saving buildings. So we insulated every part to reduce the energy consumption. You see this energy table. Before we were here, and after the refurbishment, we are here. So this is optimization from orange to light green. So zero energy would be here, but this is not possible for that kind of existing buildings. But for new buildings, we will do. We can build that with zero or minus energy. At the end, in sum, we had a saving of 1/3 of the existing energy. That sounds not that much, I know, but you have to imagine we have light energy for lamps. We have the elevator energy. It is new energy. We added new engines in the building, so we have new consumption, which we didn't have in the past. We added new apartments, And warm water demand is always the same. So for shower, for washing, and so on, the warm water is always the same. But the heating demand is reduced very high. So in total, we will have 1/3 less energy demand than before. And this is for an existing building is really good. So we have an existing building refurbished. We have 6 new apartments added, and we have 1/3 less energy consumption. Another thing is sound. Sound insulation is very important, and it's by law. Everyone has the right to have enough sound protection. Our building is here. This is the airport. Our train station is here, approximately here. We talked before. And the planes are coming and landing. So they are passing our project, and it's really loud, and we need sound insulation of outer elements of 48 decibels. And we don't have a concrete system. We have a lightweight system, and so we designed the timber frame construction for 48, the brick system for 60 decibels, so it was safe enough. This is the outer sound, the exterior sound, but we have also the interior sound. Interior means between apartments, so you see the existing concrete slab. You need the new timber slab. So here's apartment number 1. Let me do it by, so we have apartment number 1, we have apartment number 2, 3, and 4, and they are divided by a concrete slab here, and a wall here, and a wall here. But we have the sound propagation ways. We have that way, we have the direct way, and therefore, and we have the way down to this apartment. We have also the way to this apartment, from apartment 1 to 3. And the solution here was to use elastic separation, a sound insulation material, and special bearing elements to protect the apartments 3 and 4. Because these apartments 3 and 4, they had only a roof. They had no neighbors above. Later on, they will have neighbors, and they don't want to hear the new neighbors, or they want to. We should avoid the sound propagation from apartment 1 and 2, and therefore we build it that way. We have also a screed with structure-borne sound insulation, also here. And this is a system we checked also on site. We made sound measures, and it is really good. We had a very high, you can say, luxury apartment standard sound insulation level after this. Other challenges, fire escape. I told about the staircases. We checked the fire escape, and the fire department, they said, okay, if you add a new apartment, we will check this entire building again and look if every apartment is the evacuation of apartments is possible. And the situation is that we have these 3 new staircases. And later on, we have also these areas where the fire department can install a railing system to evacuate the people from the new balconies. It's a second escape way. So in case of fire in the staircase, in case of smoke in the staircase, the people, they are running to the balconies, and they are waiting that the fire department or the fire fighting team will evacuate them. This is the solution here. And 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 this is the solution here. Another thing is the entire MEP system was 60-year-old, so we need to change every pipe, every wire, electrical installation, also in the existing apartments. And this was a big issue because there were people living in these apartments. So it was done step by step, and it was room by room done. So it was a hard construction stage, because it was done also in the existing apartments. You see tons of installation and details. It's very complex, but at the end, the people accepted this because they got new installation. They got a new electric installation. So the people of the existing apartments, they accepted this works. And some pictures. You see here the existing building. Here, this is the existing building, the concrete extension of the staircase, and the concrete slab, which we put on the existing the timber slab, which we put on the existing concrete slab. And after a few days, you see the concrete rooftop timber rooftop apartment. It was less than 1 week. As I said, all the drainage, installation, MEP, also the system under the soil needs to be done completely new. So everything was done new, because it is after 60 years, there were some broken. So we decided to do all the things new. Okay, I want to show a photo. This is a photo from 3rd of February. It's also the latest photo. So you see the existing building. It looks like a new building, but the white area or white part of the building is more than 60 years old. And we have this rooftop apartments. We have the new balconies. There's still some works, landscaping work ongoing, but I think in a few weeks it will be finished. And then we will have a 60-year-old building with 6 additional new apartments with energy efficient building, very sound insulated, very good sound insulated. We will have no apartment with stairs. You can enter, even a handicapped person can enter the apartment. What can I say again? We have fair prices for the rentals. So it was a small but very important project. And we did a lot of projects that way. For example, the Wallstraße. This was the situation before. This is the situation after. So we cut the roof. We added rooftop apartments. We cut the balconies and made extension, made bigger balconies. And now after this refurbishment, it's a energy efficient, fireproofed, fair price with bigger balconies and additional apartments. So it's a win-win situation for the owner, also for the tenants. Here you can see the rooftop apartment made in timber, and you see we have done a lot of projects. You see 1, 2, 3 buildings where we did that kind of system. Another sample is am Schönen Rhein, is also a project where we use this timber structure. It's a 3-story timber structure. It's a so-called timber concrete hybrid structure. So it's not 100% timber. It's not 100% concrete. It's a combination of, let me say, a composite structure. So I'm done. Do you have some question?
There is some question. There is some question in the chat box.
Okay, open the chat. One moment. Where's the chat?
It said that when it comes to the renovation of the cladding, you mentioned that more insulation was added to the building. How did you deal with the existing moisture problems in the exterior wall? Assuming that the certain apartment has moisture problem, there must be similar moisture problem in other parts of the building also.
So our moisture here, it's not comparable with moisture in Thailand. Our moisture here, we have dry air outside and we have air with high humidity inside. So when the people are, we have small apartments with a lot of people living in a small area. So we have cooking humidity, we have humidity caused by shower, also breathing, we produce humidity. And in these small apartments with lot of people, the humidity rate is increasing. At the same time, we have cold air outside, cold and dry air outside, and this was the problem of the humidity. And we solved this problem because we use special material for insulation. We use mineral wool, not polystyrene. We used glass wool and stone wool, and removed all this plaster, damaged plaster, and added humid insulation material. And the good thing, timber structure is saving humidity. If we have an increase of humidity, the timber is like a storage for humidity, and it gives it back if the humidity decreases. In Thailand, the situation is different. In Thailand, we have humidity outside, so we have to think another way. We have higher temperature sometimes outside than inside, so the humidity transfer may be in another direction. So you can't use the system we used in Germany in countries like Thailand. So I made a project in Singapore and in Philippines, and I know that we have to think another way.
Thank you.
So,
And,
other questions?
Yes, about the DGNB standards. Like, have you considered having DGNB standards for these projects for existing building?
DGNB standards was not considered for this existing building. We used the KfW 70 named standard. That means KfW 70 means we have 30% less energy consumption, or we are 30% more sustainable than a new building done with the new codes, building codes. But DGNB was not used here. Also not for the train station, unfortunately not. DGNB is used for buildings which will be sold on the market. So if you build a building and you want to sell apartments, or you want to sell the entire project, DGNB or LEED and BREEAM are very important. But if you want to keep the building, and it was the aim of our clients, German Transportation Railway Authority wants to keep the train stations, and also CKS project, the owner wants to keep the building. So it makes no sense to make a DGNB standard. Okay. Yeah, it's. I wanted to show with this small project that we are not only doing big things, we are also doing small, complex things. And the small projects, maybe for a company like us, it's not that economically good, because the earning is not that good, but it's you can learn a lot. Also, I'm more than 20 years in this business. In every project, I'm learning and discovering new things, and it makes fun.
Yes.
จันยุ้ยจะสรุปก่อนไหมครับ
ถ้าสรุปอันก่อนนะคะเกี่ยวกับเรื่องของไอ้ renovation ของ cladding นะคะคือที่พูดถึงว่าความชื้นภายนอกอาคารใช่ไหมคะคือคำถามเนี่ยถามเกี่ยวกับว่ามันมีปัญหาความชื้นภายนอกไหมเพราะว่าเขามีการแอดพวกวัสดุปิดเพิ่มทีเนี้ยเขาก็เลยพูดเหมือนกับว่ามันอาจจะตรงข้ามกับไทยเพราะว่าอากาศภายนอกเขาค่อนข้างแห้งส่วนมากความชื้นที่เกิดขึ้นในประเทศอย่างเยอรมันเนี่ยมันก็คือเกิดความชื้นจากภายในมากกว่าจากครัวจากห้องน้ำอะไรเงี้ยค่ะเพราะฉะนั้นแล้วเขาก็มีการใช้พวกคือมันอาจจะไม่ได้เจอปัญหาความชื้นมากขนาดนั้นเหมือนในประเทศเราถ้าความชื้นภายนอกแต่ว่าเขาก็ใช้พวกวัสดุอินซูเลชันวัสดุกรอเขาเรียกว่าซึมซับแบบที่กันความชื้นนะคะมีการใช้ glass เป็นแบบ glass wool หรือว่าพวกโซนวูเข้ามาช่วยเหมือนกันแล้วก็ส่วน standard เนี่ยคือเขาใช้เป็น KSW มากกว่าคือมันเหมือนกับถ้าจะผ่านเนี่ยมันก็คือเป็นเรื่องของ 30% ที่ทำให้พลังงานลดลงนะคะมีความ sustain มากขึ้นมันมี standard มากมายที่จะ apply ใช้แต่สำหรับมุมมองของ IDG DGNB เนี่ยคือเขารู้สึกว่ามันอาจจะไม่คุ้มมันเหมือนเป็นตึกเล็กเกินไปมันยุ่งยากเกินไปที่จะทำค่ะ
ครับเพิ่มเติมนะครับที่จริงมันก็จะมีมาตรฐานอยู่หลายอันนะถ้าหากว่าเป็นอาคารที่ใช้สำหรับขายหรืออะไรพวกนี้ก็อาจจะใช้เหมาะกับมาตรฐานไม่ว่าจะเป็นลีดจะเป็นอะไรพวกนี้นะครับโอเคมีคำถามเพิ่มเติมไหมครับเวลางวดเข้ามาแล้วนะครับผมโอเคอาจารย์จะมีสรุปเพิ่มเติมไหมครับถ้าไม่มีก็ครับก็อย่างที่วันนี้ท่านวิทยากรได้กล่าวไปนะครับผมจะพบว่าแนวปฏิบัติหลายๆอย่างเนี่ยบางครั้งก็อาจจะไม่ได้นำเสนอออกมาแต่ว่าเราก็เห็นจากรูปภาพจากคำถามอาจจะมีอะไรที่แทรกอยู่นะครับไม่ว่าจะเป็นเรื่องของการทำงานร่วมกันหรือว่าการสื่อสารจะพบว่าบ้านเขาก็ประท้วงพอกับบ้านเรานะครับผมพอประท้วงแล้วยังไงล่ะเราก็ต้องพยายามพิสูจน์ด้วยข้อเท็จจริงมีการทดสอบมีการวิเคราะห์เชิงตัวเลขมีการซิมูเลชันมีการตอบคำถามให้ชัดเจนก็คือจะไม่ได้นัวนะครับผมก็จะเห็นว่าหลายๆอย่างเนี่ยแนวทางปฏิบัติก็จะค่อนข้างตรงไปตรงมานะครับผมมีข้อมูลนะครับ At the end of the seminar, I'm very grateful you to took your time of your busy schedule to address our small special interest group. On behalf of Faculty of Architecture, Silpakorn University, I would like to thank Mr. Ramazan Balci for his insightful lecture. See you next for the next activity of CIBCT. นะครับก็ในช่วงสุดท้ายนะครับก็สำหรับกิจกรรมอันถัดไปนะครับก็ทุกท่านก็สามารถติดตามได้นะครับในเพจอันนี้ผมโพสต์ในส่วนของในแชทนะครับผมในแชทเป็นลิงก์การประเมินการสัมมนาครั้งนี้นะครับยังไงรบกวนทุกท่านเข้าไปประเมินการสัมมนาครั้งนี้ให้หน่อยนะครับผมสำหรับกิจกรรมอย่างที่ทราบนะครับว่ากิจกรรมเราก็จะมีเรื่อยๆนะครับของศูนย์บูรณาการเทคโนโลยีอาคารและการก่อสร้างก็ท่านก็สามารถติดตามได้ในรายละเอียดของเพจคณะหรือเพจของหลักสูตรนะครับซึ่งทุกท่านก็จะได้รับลิงก์เพจของคณะหรือหลักสูตรในอีเมลทุกท่านอยู่แล้วนะครับผมแล้วก็อย่าลืมประเมินการสัมมนาครั้งนี้ด้วยนะครับทุกท่านสามารถชมคลิปย้อนหลังนะครับผมได้ในเพจของคณะและหลักสูตรเช่นกันนะครับก็ขอบคุณทุกท่านเลยนะครับจะจบแบบพ้วนๆแบบนี้เลยนะครับผมเพราะว่า 5 โมงแล้วก็ขอบคุณทุกท่านนะครับที่เป็นส่วนหนึ่งในการพัฒนาอุตสาหกรรมก่อสร้างในประเทศต่อไปนะครับผมต้องขอบคุณทุกท่านมากเลยนะครับ Vielen Dank
Danke auch.
Yeah, maybe next seminar. I'm not sure when I have to see the feedback for the seminar. Yep, and I will make a contact to you again. Yeah.
Thank you very much.
Yeah.
Bob, hope to see you in Germany.
Yeah.
And,
Yeah.
say hello to all of my friends
Yeah.
of your former company GEL,
Yeah.
and see you.
See you. Ciao.
Thank you. Bye bye.
Bye bye. โอเคครับทุกท่านอย่าลืมนะครับผมรบกวนประเมินให้นิดหนึ่ง